Go outside on a clear night, and nearly every point of light you see is a star, and almost none of them is a place we can ever reach. Telescopes can measure them, name them, split their light into colors, and read what they are made of. We just cannot go to them, not with anything we know how to build, and maybe not ever. The night sky is the most beautiful locked window in existence. We spend our lives looking through it, and this is the story of the glass. We've never been content to just look. In 1977, we launched 2 spacecraft, the Voyager probes, and aimed them at the edge of the known. They are the fastest, farthest things our species has built, racing outward at roughly 38,000 miles per hour, covering about 1 million miles every single day. They have flown for almost half a century without stopping, and after all that time, all that speed, they've barely cleared the end of our own driveway. We like to believe space has been conquered. Boots on the moon, robots on Mars, and I like the James Webb Telescope reading light from the dawn of time. But step back far enough and the human story looks very different. Our species is not spreading across the galaxy. It is one population on one rock sealed inside a system there may be no way to leave. This is not a story about how far the journey has gone. It's about the walls we keep slamming into and why the universe may have locked the door. The first wall is the one we are born at the bottom of. People tend to picture space travel as a problem of distance, as if leaving the solar system were just a matter of driving far enough. The real problem is energy, and it begins with the sun. Every massive object bends the space around it, and the sun, holding more than 99% of all the mass in the solar system, bends it enormously. Think of a heavy ball dropped onto a stretched rubber sheet. It sinks down and carves a deep, steep funnel, and everything nearby rolls toward the center. We're living partway down that funnel, and so is every planet, every comet, every probe we have ever flung outward. To climb out, you have to fight that slope the whole way. Physicists call the speed you would need to break free the escape velocity. And near the sun, it is savage. Even at our comfortable distance, tearing loose from the sun's grip means moving at around 94,000 miles per hour in the right direction. And that is just to drift away slowly, not to actually get anywhere useful. The deeper into the funnel you sit, the steeper the wall becomes. This is why leaving Earth is only the very first step. A rocket crawling its way to orbit burns most of its fuel just to rise a few hundred miles. The Voyagers escaped the sun's pull at all only because they stole speed from the giant planets, swinging past Jupiter and Saturn and using their gravity like a slingshot. Without that free kick, nothing we have launched could have made it out into open space. It helps to put our very best efforts in perspective. The fastest object human hands have made was not a Voyager at all, but a probe called Helios, which whipped past close to the sun at roughly 150,000 miles per hour. That's blistering, and it is still nothing. Only 5 craft in all of history are even on a path to leave the solar system, and every one of them will need tens of thousands of years to drift anywhere near another star. These are the crown jewels of our space age, and the cosmos treats them like dust on the wind. Look honestly at the energy budget of a real journey and it turns absurd. To send one human crew on a true interstellar trip, you would have to carry and burn a quantity of fuel so staggering that no chemical rocket could ever lift it. The faster you want to travel, the more fuel you need, and that fuel has weight of its own, which demands still more fuel to push it. The numbers spiral into fantasy. We're standing at the bottom of a gravity well so deep that with the tools in our hands, the rim is effectively out of reach. Suppose you found that impossible amount of energy anyway. You would still have to cross the solar system, and few people grasp how staggeringly large that truly is, because we have been measuring it wrong our whole lives. Ask where the solar system ends, and most people will say Pluto or maybe the heliopause, the boundary where the sun's wind of charged particles finally thins out. The Voyagers crossed that heliopause years ago, which is why the headlines cheered that they had entered interstellar space. But that is not the true edge of anything. Gravity reaches vastly farther than the solar wind does. The true border of the sun's domain is a structure called the Oort Cloud, and it barely feels real even to the scientists who study it. It's a colossal spherical shell of icy debris, billions upon billions of frozen objects wrapped around the entire solar system like the rind around an orange. Its inner edge may begin 1,000 times farther out than Neptune, and its outer edge reaches as far as 1 to 2 light years from the Sun, perhaps a quarter to halfway to the very next star. As NASA bluntly puts it, much of interstellar space is actually inside our solar system. Now let the scale land through time instead of numbers. The Voyagers are the fastest objects we own, crossing 1 million miles a day. At that pace, they will not even reach the inner edge of the Oort Cloud for about 300 years, and they will not pass all the way through it and truly leave the Sun behind for something like 30,000 years. 30,000 years just to clear the outermost suburb of our own star in our fastest ship after already flying for half a century. It's not even an empty shell out there. The Oort Cloud is the source of the great long-period comets, the ones that fall in toward the Sun once in thousands of years, blaze briefly across our skies, and vanish again into the dark. Countless icy bodies coast in slow, lonely orbits so far out that the Sun is just a slightly brighter star among the rest. They were flung there in the chaos of the early solar system, scattered outward by the giant planets, and then parked in the borderlands by the faint pull of the galaxy itself. A frozen wall of our own making, one we can barely see and may never touch. So when we say the Voyagers have left the solar system, we are flattering ourselves badly. They have stepped out the front door and reached the edge of the lawn. The fence around the property is still 3 centuries ahead of them, and the far side of it is a trek longer than all of recorded human history laid end to end. This wall is not built of stone or fire. It is built of pure, suffocating distance, and it surrounds us in every direction at once. It would be easy to hear all of this as pure despair, but there is something quietly thrilling buried inside it. We are about to hit 2 more walls, and they are stranger than the first 2. One is written into the laws of physics themselves, a speed limit the universe enforces on every object that exists. The other is written into our own flesh and blood. Stay with this, because the deeper we go, the clearer it becomes why one small world matters so much. Suppose we cheated all of it. Suppose tomorrow someone handed us a miracle engine that ignores fuel and gravity completely, a drive that can push a ship as fast as the laws of physics allow. We would still be trapped because the universe enforces a hard speed limit, and there's no appeal. Nothing that carries mass is allowed to travel as fast as light. As you push an object faster, it takes more and more energy to speed it up further. And the closer you creep toward light speed, the more that cost balloons toward infinity. Reaching the speed of light would demand infinite energy, which is simply another way of saying it can never be done. Light itself is the fastest thing there is, tearing across space at about 186,000 miles per second, and it sets the ceiling for absolutely everyone and everything. On a human scale, that sounds impossibly fast. A beam of light could circle the Earth 7 times in 1 second. But carry that same speed out into the gulf between stars, and it turns agonizingly, cruelly slow. Sunlight takes about 8 minutes to cross the distance to us. To reach the nearest star beyond our own, Proxima Centauri, that same beam of light needs more than 4 years of steady travel. Sit with what that actually means. Even at the absolute maximum speed the universe permits, a speed no physical ship can ever truly reach, the one-way trip to the closest neighboring star takes over 4 years. Proxima sits about 25 trillion miles away, nearly 270,000 times the distance from the Earth to the Sun. Our fastest real probe, the kind that needs 30,000 years to merely exit the Oort Cloud, would take more than 70,000 years to arrive if it were even aimed in the right direction. It's not. There is a famous twist hidden in the physics, and it does not rescue us. As a ship approaches light speed, time aboard it would slow compared with home. So, in principle, a crew could feel a shorter trip than the clocks on Earth record. But you can never actually reach that speed, only crawl toward it at a ruinous price in energy. And from the viewpoint of everyone left behind, the journey still drags on, year after year, for every star. Relativity bends time at the very edges. It does not unlock the door. To make that emptiness land, shrink the picture down. Let the Sun shrink to 1 grain of sand on the vast dark floor. On that scale, the nearest other grain, Proxima, would lie miles away across nothing at all, with no planets, no way stations, no islands in between, just black, freezing vacuum running on and on. That void is the true moat around our world, and the speed of light, the fastest motion the cosmos will ever allow, is the quickest anyone could hope to row across it. Even if we shrug off the speed limit and accept the voyage of centuries, one final wall is waiting, and it is built into us. The human body did not evolve for deep space. It evolved for this exact planet, and it begins to fail almost everywhere else. Beyond the Earth's protective magnetic shield, space is drenched in radiation, a constant sleet of high-energy particles from the sun and from distant exploded stars. On a long voyage, that radiation rips through living tissue and damages DNA, driving up the risk of cancer and quietly wearing the body down. On top of that, the absence of gravity wastes muscle, thins bones, and weakens the heart over months and years. We have learned an enormous amount keeping astronauts healthy for a year at a time in low orbit. A journey between stars would last not months, but many lifetimes stacked one after another. That is the part most people never quite absorb. A realistic starship, creeping along with any engine we could actually build, would take centuries or far longer to arrive. No crew could possibly survive the trip. You would need a generation ship, a sealed metal world where people are born, grow old, and die in transit, passing the mission down to their children who would pass it to theirs for dozens or hundreds of generations. The travelers who finally arrive would be remote descendants of the ones who departed, strangers to a home they only know from stories. It is less a spacecraft than a flying prison handed down through the centuries. And our genuine engines make even that sound generous. Chemical rockets, the kind that launch everything we fly today, are hopeless across interstellar distances. They roar for a few minutes and then they are spent. Cleverer ideas exist on paper. Ion drives sip their propellant and push gently for decades. Nuclear designs could do better, though one famous concept would ride on a string of detonating atomic bombs and still take a lifetime to arrive. There are bold schemes for gram-sized probes shoved by giant ground-based lasers onto sails of light, perhaps reaching a fifth of light speed. Yet every one of these is either still trapped on the drawing board or built only to fling a featherweight robot, never a living crew into the dark. Run the arithmetic on a crude trip and it turns dizzying. At Voyager's speed, a one-way crossing to the nearest star would span more than 2,500 human generations, an unbroken chain of people living and dying inside a steel hull. Even the wildest Sirius proposal, a ship riding a string of atomic blasts, would weigh hundreds of thousands of tons, most of it warheads, and cost more than entire national economies, all to carry one crew across one gap to one star. And the laser sail probes that could move fast enough have no way to slow down at the far end. They would scream past their target in a blur and keep going forever. Strip the optimism away and the picture is severe. We've never sent a person beyond our own moon. Everything farther has been machines, and even those will drift for tens of thousands of years before they so much pass another star. The very body that lets us thrive on Earth is the same body that makes the rest of the galaxy almost lethal to us. So, put the four walls together and look at them all at once. The gravity well runs too deep to climb with any fuel we can carry. The solar system spreads so wide that our fastest ship needs 30,000 years just to leave it. A cosmic speed limit makes even light feel slow, and our bodies are far too fragile to survive the crossing, even if everything else were solved. 4 locks on the same door, and we hold the key to none of them. Strangely, we have already mailed ourselves out into that dark. Bolted to each Voyager is a golden record, a greeting carved in sound, an image for anyone who might one day find it, a message in a bottle thrown into an ocean too wide to cross. One of those probes also turned its camera homeward long ago and caught the Earth as one pale dot adrift in a sunbeam. The whole human history balanced on one fragile speck. Both gestures say the same quiet thing. We know how small and alone we are, and reach out anyway. It's tempting to read that as a sentence, the idea that we are castaways marooned on one small world in an ocean so wide we cannot see the far shore. There is another way to hold it, though. If this is the only home we can truly reach, then it's not merely where our journey began. That is the whole of it. The Earth and its handful of sibling worlds are not a launch pad to somewhere else waiting out in the dark. For every practical purpose, they are the entire stage our story has to play out on. That quietly changes what the solar system is. It stops being a waiting room and becomes the house itself. the only house, and a house has to be cared for. The same isolation that traps us is the very thing that makes this place precious beyond any measure. We're not so much stranded in the cosmos as we are deeply, completely at home in one small, warm, irreplaceable corner of it. And learning to keep that corner alive may be the most important thing our species ever does. And we still keep reaching anyway, flinging our little machines toward the dark just to see how far they can get before the silence swallows them. If these walls leave you wondering what is waiting out there beyond them, that is exactly where we go next in our video on what lies beyond our solar system. It's the perfect step from right here.